Okay, another quick sound check for anyone who may or may not be out there. If you are listening, Powerful K9, thank you. If you can sing out, let me know whether or not the music's too loud or the voice is too quiet or vice versa. That will be loud and clear. Fantastic. I do sound terrible. A little low. Okay, so maybe let me just have one of the things is like my mic is currently on max, so I'm wondering if I do something like this, does that actually help? It's a little quiet, so I've got the microphone volume according to OBS cranked up as high as it can go. That's not any better. I should probably read the instructions on this thing at some point, shouldn't I? Hang on just a minute. Let me see if I can do something here. How about we go like this? How's that? Did that make any difference? According to what I'm seeing on screen over here, apparently it should. That's pretty good. Okay, let's stick it to that, and I'll let that run behind the scenes and see if that makes it. Yeah, that's better. So you can hear me a lot clearer over the top of the music. All right, let's run with that. Move this window down a little. Okay, cool. All right, let's run with that then. Okay, so you can't hear the music. Sounds great. Some people can't hear music, some say they can. I'll just leave it like that. Hopefully that will. Sounds great. Okay, all right. I'm gonna stick with that. Okay, as long as you can hear the voice, I guess the voice is technically more important than the music. Although arguably the music is much more interesting than the sound of my voice. Okay, so when we left this off last, I had bashed my head against a few issues. One was related to name pipes and things like that. Other things were to do with the way sessions were working and whatnot. But we're at a point now where some exciting things are going on. So before we start dev, I'm going to show you where we're at. So as you can see here, I've got a job running here, which is just a plain reverse TCP connection listening on 8443. So this will just give us a plain old Meterp session. So if I go to my Windows machine, I should be able to spin this one up, and we end up with a session. Okay. That's nothing particularly exciting, and please try your best to ignore all of this noise, but this is here for a good reason. I'm just making sure that packets and whatnot are coming through as expected. There's a lot of debug output coming on. Okay, so even though I haven't exposed this in the UI, and this is something we're going to hopefully figure out today, we can go into the session, drop into IRB, and we can create a new pivot. So we can go create named pipe listener. Now I don't know whether I'm going to keep it at this name, but for now that's good enough. So what we need is we need to give it the current client instance, so the pivot will attach itself to the current session, and then we need to give it some options. So the options I'm going to give it are architecture, which is x86. Oh, there's a packet that's just come in. Don't you hate that? The next thing we're going to give it is a pipe host, which is 10.1.10.56. I'm going to be running this on the same machine. Pipe name needs to be pipe test. And what else did I need to give it? Platform. Platform is Windows. So this is all relevant for reasons which I'll explain later on, but on hitting enter here, it should actually create the pivot for me. Okay, so there we go. Core pivot add actually has gone out. So if we come back over here, we should be able to fire up Process Hacker. I like to run that as admin because reasons. If we open this up, we should see, there it is, pipe test. Okay, so we've got a name pipe sitting there ready to go. Now, because I like to separate my output and because I still haven't regenerated my payload without the breakpoint in it, I'm going to open up this pipe stager in a debugger. So I'm going to hit F5, and here you can see we've reached the beginning of the stager. And then from here, if I hit F5, we should see a bunch of magic happening. See all that? There's standard API being loaded, all kinds of things going on. So if we go back over here, exit out of IRB, background that session. Whoops. Sessions -v is clearly broken. There we go. We have a second session, and you see it's got this 127.0.0.1, which we are going to fix up as part of our pivot session output. But here you can see it has actually picked up the stuff behind the scenes. Now let's drop into that session, and what can we do? Let's transport list. I may well have just broken it because I don't even know where that. There you go. So it failed to list transports, which is a bit of a shame. I was hoping it was actually going to drop in the stuff that we were looking for and spit out that it was part of a named pipe, but obviously that is not what's going on. Something else is happening. But what you did see, I hope, let's run it again. What you did see is that we did actually have a session. Did we get another one? Nope. So obviously we've got work to do here. But the point is that we do actually have a functioning session. I'm going to kick this puppy off again. I'm going to do the copy and paste thing if I can. Track down where it is. Geez, look at all this magic that's going on behind the scenes. Session 3 apparently opened, but I didn't see it appear. Where are you? Save me typing. Should whack it on a clipboard somewhere, shouldn't I? Oh man, there's a lot of output here. Here we go, getting to it now. It should be somewhere around here. There it is. I'm gonna chuck that. Oh no, it's only part of it's there because a packet crapped on us halfway through. So what I'm going to do is I'm just going to drop this in a notepad style thing over here, just off screen because it's boring. And I'll look for the rest of what I typed. In fact, I'll probably just bash it out quickly again. So pipe host is 10.1.10.56. Pipe name equals pipe test, and platform is Windows. Okay. Let's go back over here. So we should have one session. Drop an IRB, create background. We should only have one. Let's kick this puppy off again. And hopefully we'll get a valid session again. Come on, shortcuts. Okay. So I should be able to interact with it at least. There you go, there's get UID, sysinfo, PS, so we can get process listings. We can do stuff. Which directory are we in? So if we went dir, we should be able to, there you go. So we're actually getting packets out. The session is behaving itself. Clearly the listing of transports is busted, but we can fix that as part of what it is that we're doing. So yeah, that excited me, and I got to that point a couple of days ago. And I've been tinkering with some other bits and pieces since then, just trying to tidy it up. So what we're going to do now is we're going to, first of all, I'm going to fix the issue with the transport listing. So obviously calling transport list with a name pipe pivot doesn't seem to be too happy. So let's go fix that. And then I'm going to go ahead and make sure that you are able to unregister pivot listeners, disable them, and we will put some effort into making sure that when someone terminates a pivot session, that the associated packets, associated pivots also get notified of that termination. Now, I'm not talking about cases where the pivot session dies. If the pivot session dies, I want all those other sessions to still sit there and wait for their pivot window to reappear, or for them to fall back on other transports. But yeah, for now, let's go ahead and fix the issue to do with transport listing. So core transport list, I think, is the function. Righto, core transport list. Let's dive in here. So what is it doing here? No, not sleep. That's not what I want. List. Okay, so what are we doing first? If it's not TCP, then what do? We assume that it's HTTP. Yeah, that's exactly what we do. So what are we adding here? We add the URL, we add the timeouts, and that's it. This is where it's crashing. So the problem that we've got here is we effectively need to do a switch. So we can go switch current transport type. And what we want to do is check the case for Meterpreter, HTTP, or HTTPS. Okay, and in those cases, we want to take all of this stuff out of here and chuck it in there. So that means that only in those cases are we going to see any... That is ugly as sin, isn't it? I hate the way the switch statements nest themselves. Okay, so that means that only for HTTP and HTTPS transports are we going to dump this extra stuff out. What we're doing here, we've got the URL, which is really all we're interested in. The timeout, the retry total, and retry wait. I don't think there's anything specific to name pipe transports that we care about. So the fact that we fenced this off now means that this code shouldn't run, and hence it won't try and convert a HTTP transport, create a HTTP transport out of a name pipe one, and we won't see crashes. So I hope that makes sense. But that really should be the fix. So we're just making sure that we're not trying to read things like cert hatches, proxies, etc. out of a transport that doesn't support them. And there's no doubt that that was the source of the issue. So I'm going to create another pivot session in just a minute. Now we should be able to create multiple pivot sessions off the same listener, and that's another issue that looks like we need to address. But in the meantime, what I'm going to do here, excuse me, is I'm going to exit. Would you look at that? So when I exit, what this is trying to do is see how often it's calling core shutdown. Let's just kill all that off. And clearly this is not production ready. So let's just make sure we've got everything closed over here. We don't. So as you can see, I mean, the work that's gone into this so far has been pretty rudimentary insofar as we have the ability now to actually put packets on a wire and route in various directions. But some of the flow isn't working correctly. So like when you kill off a pivoted session, what does that mean? So we want to exit the session. When we exit the session, we need to pivot that packet through, and when it's done, we need to terminate the session properly. And given the session is a pivot session, there might be more metadata handling or some other kind of cleanup that we need to worry about. But we'll get to that. We'll get to that a little bit later. So now that our new binaries are built, let's go back here. Make install Windows. Okay, let's kick off another TCP session. Grab a copy of the command so I don't have to type it out again. Sessions -1. Create the pivot. Okay, and let's kick this off again. Okay, that's looking good. And transport list. Oh, hey, there we go. So we can see we've got our session expiry, and there's the full list of all the transports. So pipe at this location with this name. Beautiful. That was a pretty easy fix. Any questions around that, feel free to reach out as we go. As always, I've got no pings going on, so I'll assume everyone's cool with that. So with that in place, I mean, there may actually be other cases where things don't work, such as migration. In fact, this would be an interesting test, right? Let's go notepad.exe 7584. So if I try and migrate to that, bets on or off that this is going to work or not. I'm going to go with no. Ooh, I'm not surprised. But I thought, ooh, core migrate did actually come back with a successful result. But clearly something is broken. Anyway, why not? I thought I'd give it a try. Why not, right? Let's kill off the sessions. All right. Anyway, oh, look at that. Notepad stopped working. So clearly the migration code is busted, but that's not surprising either, given the amount of butchery that's going on. There could be all kinds of other bits and pieces, and it could be as well that the code that picks up the handle on the other side isn't doing its job, but we'll figure that out. That's not a big deal. What I'm going to do is, at this point, we might just commit this change here. Can't type. Yeah, so we definitely want that change in, so I'm gonna add that. Let's go fix transport list command to support named pipes. Oops. Don't you hate it when you're trying to type long passphrases on screen and you constantly fail? There we go. Okay, so let's store that. Make sure that that's all pushed up. Now you can see over on this side, I got a lot of standard error puts and whatnot. This is my go-to for debugging. It's pretty neat. Anyway, so we know that we can create sessions. We know that we've got some metadata handling to muck around with first. But what I'd like to do now is make sure that we have the ability to keep track of listeners on the target side so that we can effectively turn them on and off. We need to be able to list them locally as well so that we can say, hey, can you give us a list of pivots? So first thing I'm going to do is work on the Meterp side, because this is where we also need to keep track of things on this side so that we know which pivot to remove. Okay, so let's open the pivot. Now we have attached to our remote instance, which I'm sure I've got a pointer to somewhere. There's one. Okay, so our remote instance, as you can see down here, we have a list of pivots. So what I'm going to, instead of calling this pivots, I'm going to call this pivot sessions. Pivot sessions. And I'm going to have another one called pivot listeners. Collection of active Meterpreter pivot listeners. Okay, so we've got two pivot trees, one that keeps track of the sessions and one that keeps track of the listeners. So when we create a new listener, which we handle over here in request call pivot add named pipe, we actually get given a pivot identifier, which is a GUID. So once we've created it, assuming that everything works, at this point, we need to add a new instance. So we want to be able to go pivot tree add. We've got to give it a reference to the tree, which would be the same as remote pivot listeners. We need to give it the pivot identifier, which is in pivot ID. And we need to give it a new pivot context. So we've got to go and create one of those. Pivot context. Okay, so pivot context pointer. Let's do the calloc thing. One size of one of those. Okay, so we create one of those. I'll check for null very shortly. But pivot context needs to contain, packet write and state. I'm going to leave packet write as blank. We really only care about the state here. We're going to use, what is it? It is the context handle itself. So this context handle, you can see up here, is a named pipe context. That's like a named pipe server context. And we're going to add that to the pivot listeners. Now, one thing we need to do when we set up our remote instance, which we should find, I believe, in remote.c, remote allocate. So here we've got remote pivots. We need to change those to pivot sessions. There'll be a few instances of that. And then we're going to have to duplicate this for listeners. So if that exists, listeners, whoops, messed that up, didn't I? Vim foo failing me today. What else? Pivot tree destroy. And that should be it. So we're kind of hijacking our existing pivot session tree to be used for pivot listeners, which isn't really a problem, because we're effectively just reusing the binary tree to handle listeners. There is an interesting edge case that we need to handle here, though, because remember, when we have a server context that contains information about named pipes, when a new session comes in, that server handle becomes a client handle, and you've got to spin up a new server handle. So we have code in here that does all that for us, but what we need to do is make sure that when we get a session coming in, and we create a new listener, we have to update the context associated with that pivot ID so that it points to the new listener and not the old one. So this should be done, I believe, down here. Here we go. Pivot. We should change this to pivot sessions. Now, so here we go. Where are we? Where's the new one created? It's in here somewhere, I'm sure. Here we go. New context. Next context. So this is the next instance that is going to be listened on. So we know that the server context that's associated with the current pivot listener identifier is pointing to that current server context, which now has a session established. So at this point, what we need to do, once that's been established, is we need to go pivot context pointer. Let's call this listener context equals pivot tree find. We need to give it remote pivot listeners, and we need to give it the GUID of the server context pivot ID. So that should give us a reference to the tree, to the why is that not working? GUID is incompatible. Okay, right. That'd be why. We've got to do some classic casting. What's wrong now? Invalid type conversion. All right, so the pivot ID is a GUID, so we need to give it an address. There we go. So assuming if listener, this should never fail. If listener context doesn't equal null, there should never be a scenario where the listener context is null, because the listener context should be in the tree prior to this code actually kicking off. So what we need to do is go listener context state, which currently points to this server context instance. We need to update it so that it now references the next context. Okay. One question we have here is, are we wrapping this in a lock? Now, at the moment, we're not currently wrapping this in any form of lock, which we probably should do because we don't want new sessions sort of coming in and mucking with the server handles while we're updating them. But I'm pretty sure that's not going to happen. But we will add some locking to this to make sure that we have a couple of critical sections in place that only allow for, one thread to come in here and do things at once. Still no questions? That's good. Okay, so with that update, I should probably add add some context via a comment. The current listener context in the listener's tree points to the server instance that has now become a client instance due to the new connection. Therefore, we need to update the pivot tree, if I can type correctly. This kind of listener's server instance that now become a client instance due to the new connection. Therefore, we need to update the pivot tree context to point to the the new listener on the named pipe. Hopefully that's fairly self-explanatory. Pivots, there's clearly more cases where pivots. Okay, we fixed that one. Too few arguments for call. Oh no, that's good. This one here we go. Pivot sessions. Okay, so that's because we updated our pivot variable inside remote. Okay. While that's doing its thing, I think what I might do is open up the reverse named pipe payload. And let's cruise up here. This is pretty ugly code. And let's do this just for now. We'll get rid of the that breakpoint so I don't have to fire it up in a debugger. So Venom, reverse name pipe, blah blah blah, pipe test, no CC. Okay, we'll generate that payload. Ignore this debug output, by the way. So we can see I've got that sitting there. Now what I'm going to do is try and improve on my OPSEC. I'm going to click that while I do something because I don't want to expose something. But I am still here. Hopefully you can still hear me. Let's just open this up and grab this. I'll get over there. And we are good. Okay, sorry about that. So that one there has the breakpoint baked in. This one here does not, and there's a TCP instance that we had before. Okay, let's just fire that up again. How many people do we have in attendance? 15, that's not too bad. Okay. Just make sure that that works. Start to get rid of some of this debug output soon. So this should not break anything. And by the looks of it, it hasn't. assuming that nothing crashed over here. Oh, yeah, we can close this debugger off at least. And there we go, pipe test is there. So I'm hoping that we can assume that we're keeping track of the listener appropriately. Excuse me. Okay, so now if I spin this up, a lot of stuff's obviously going on behind the scenes. We need to exit out of IRB, background. Okay, good. So we have our second session sitting there. Very shortly we'll go through and change the session output so that it becomes aware of the underlying transport. So what we'll probably do is have the ability to say, because we know that this session has a reference to this session, we can probably take this information and basically imply that this is related to this. So perhaps somehow while we're doing this, we'll keep track of it and say, okay, well this session here was ID 1. Maybe we can put the name of the named pipe here and go via session 1, for example, so that we know it's pivoted. Splat. Greetings, mate. How are you? All I hear are things are getting exposed. Yes, well, you joined right at the perfect time, didn't you? Okay, so what we need to be able to do now is we need to be able to list active pivots, and we need to be able to what else do we need to be able to do? We need to be able to remove them based on some kind of identifier. Now at the moment we don't have anything in place that stops people from creating pivots of the same name, but we've got to assume that someone knows something about what they're doing. But in the meantime, let's come in here. So when we create this name pipe listener, we have a bunch of options that we chuck into the stager to generate the payload. I think what we might need to do, you notice here that I've commented out this UUID. I think that does actually get generated appropriately, which is why I've removed it. It gets generated by the stage based on all the options that we've specified. So we can get rid of that now. Let's get rid of a couple of these as well. Okay, so once we've created a listener, we track the pivot listener as part of the current session. So we need to be able to provide some kind of interface that says, give us a list of the pivot listeners associated with this thing. So add pivot listener is part of the pivot container. Find pivot. Now we've got a pivot listeners reader here, which means we should be able to quite easily iterate publicly through all of the listeners that are associated with the session. But we might need to add, I might store these stage ops here, which is more than just stage ops, it's effectively pivot ops. And we'll put that alongside the pivot itself. So session class, and we'll give it the stage ops here. Whoops. And because we're effectively using this as a way of highlighting what was involved, we might actually need to include some kind of type in here so that we know what the data store contains. As you can see, I forgot to mention, I had to add a bunch of stuff in here to make the stage generate correctly with all the appropriate expirations and whatnot. Technically, each of these things should be exposed with an option, which I'm ignoring for now. The way that I've set it up is so that if you create a pivot, then it will adopt basically the communication and session expiry settings that are associated with the session that you're pivoting through. That's what I'm going with at the moment. I think it's fair to say that at some point you'll be able to drive all of this stuff in the usual manners. Now, the more that I'm seeing this, the more I'm thinking it might be worth creating or reusing the existing handler and payload infrastructure to create the pivot. But I'm kind of hesitant. I didn't like the way I did that in the past. I'm just trying to find a nice way of saying I want to tie this payload and whatnot with this session without having to force people to specify all of this garbage at the same time. But we'll get back to that. So where are we at? We need to pass in the stage ops when we add the pivot listener. Stage ops. We'll still call this stage ops for now. What we may need to do to generalize this, we might not even need to. Do we actually need all the options? Maybe not. Maybe we just need some kind of, display, so to speak. Some sort of visual identifier that says this is what this happens to be. So maybe I'll change it to that. So instead of stage ops, we'll just call it display name. And then we can leave that up to the individual types to generate that display name. So, for example, display name can be a bunch of stuff. Pass that in. Display name. So what would we want this to be? You effectively want it to be, maybe we can make it look like the transport. That's pretty much all we need, right? I mean, the host that it's on is the current session. But yeah, if we go ops pipe host there, ops pipe name here. Maybe we can, in brackets after that, put something like the architecture. Architecture and platform, like we did before. Did we do arch platform or platform arch? What does it look like when we get the sessions output? Arch platform. Let's do that. Arch. It's hard to fit all this nicely into one line, isn't it? Ops. Platform. So then the display name will be listed here. We should store it. Self.display name equals display name. So that means that we have the ability to just loop through all the pivot listeners and draw them effectively. And that will give us the ability to say, hey, I want to get rid of this particular pivot listener. So we'll need a function instead of create, delete, remove named, remove listener. What is this going to be called? We'll call it the pivot ID. Is that what we called it before? We'll call it listener ID. Okay, so if where's the first thing we want to do is find it, right? So that's in here. Can we do this? Find pivot listener. Yeah. So equals find pivot listener, which I think we're using elsewhere, aren't we? Client dot, yeah. Client.5 pivot listener, listener ID. Okay, what does remove look like? Removes a pivot, removes a listener. So I can't remember whether or not dictionaries barf if they don't exist. So let's go client.remove. Is it remove? Find pivot listener, add pivot listener. We haven't added remove pivot listener. Hey chickens. listener ID, pivot listeners. So we remove the pivot listener in the same way. Client.remove pivot listener. I'm guessing, see, it is given as the ID, so maybe we don't need to do that. Actually, yes, we absolutely do. Then again, if we have the ID, maybe we don't need to find it. Remove pivot listener, listener ID. So what we need to do in here is we need to create a pivot remove function, and we just need to give it, is it an ID? Yeah. Listener ID. Maybe what we should do then is if client.find pivot listener ID. So that basically means it'll return the instance. If it's not nil, then we'll go ahead and do this. Client remove pivot listener ID, create pivot ID, and then all we need to do is go client.send. I can never remember the syntax. Client.send request. Request. So this is us just saying create a packet, send it down to the remote. We should probably check the result. We don't actually need to check the result. If the result returns status success, then the next line of code will execute just fine. If not, then it will throw an exception. I think that's how it works. So core pivot remove. Core pivot remove. Yeah, we're going to need to have a function that allows for the pivot context to retain a reference to a function that will allow for that pivot to be removed, and that needs to be done in a type agnostic way. So we might end up adding another function pointer to our pivot context on the target side. But in the short term, we need to do this pivot remove functionality inside Meterp. So let's head back over here. Core pivot add. Okay, so where are we? Let's add it here. Okay. Add that to this thing here as well. I don't think we need to do that there. Actually, we've got this core pivot add and core pivot remove. That must be inside. It's in server pivot.h, isn't it? Yeah. So we add our remove function. Now here in our add, we just know that at the moment we're only supporting name pipe, so we're just kind of sending that straight through. But what we need to do, in this case, we can have a type agnostic thing. Remove a pivot point from the current Meterpreter instance. Point at the remote. It allows, yeah, we don't need that remark. Okay, so let's do the usual shenanigans. Result equals error success. Pivot tree find. So we need to find the instance of the listener inside the list of pivot listeners. And we need LP byte pivot ID equals packet get TLV value raw. Give it the packet that's just come in and tell them that we want a TLV type pivot ID. So that gives us the ID. If the pivot ID comes out blank, then we're just going to ignore it, because they haven't given us one. pivot context. Okay, so we're going to find the pivot context based on the pivot ID. Righto. So once we've got that, pivot tree remove. So the reason we need to retain the pivot context is because we need to clean it up. So now we need to remove it from the tree. So we can do the same thing, go remote pivot listeners, pivot ID. When we first started working on this binary tree, I thought what might be handy is for pivot tree remove to do is to actually return the pivot context. That might actually be worth doing, because pivot tree remove right now, it'd be great if it actually did the find at the same time, because then we don't have to find it and then remove it. So let's do that. Pivot context. Instead of error success, we'll return null. What do we got here? So the thing that we're removing, we need to go pivot context. Context equals remove context. And then we free it and then we return the context. Okay, so that means that when we call for removal of the node, we actually get the associated context that comes out of it, which I think is probably a bit more useful. That means we need to go and modify the pivot tree header here. Okay. Righto, so that means we should be able to remove the two searches and just do this. Okay, if the context isn't null, so that means did we find something, did we not find something? Then we want to go ahead and do something. Now, do we have... I haven't got anything else in here, I don't think, that actually removes pivots when sessions die. So we are going to have to do something along those lines, and that might be in the same way that when Meterpreter tells MSF that a new session's come in, we need MSF to tell Meterpreter when an old session's gone. So that's not a problem though. Okay, so if the context comes out as non-null, then it means that it's found the listener instance. So we've got to pack it right. What we want to be able to do here is go, we'll just go remove, and we'll give it the context state. We also want to give it the remote, don't we? Okay, so this pivot context we need to update. So you see packet right looks like this. Actually, we don't need to give it the remote, oops, because that's actually part of the state. So instead, let's have a pivot right packet. We'll go pivot remove, and we only need the state. Pivot remove. Now, I am conflating these pivot contexts a little bit, but I don't really have that much of a concern about it, to be honest. It's kind of operating as a generic sort of pivot container. If people don't like that, then you know I'm happy to deal with it. But at this point, we want this to be removed, and then once that's removed, we want to free the context. Okay, so the context should be free at this point regardless. And it's already been removed from the pivot tree at this point, so our listener should effectively be freed up from the metadata tracking stuff that's going on behind the scenes. Hey! I appreciate the sentiment. Thank you. Thanks for singing out, mate. And feel free to sing out with any questions as we go, as always. But yeah, I appreciate you watching. Thank you. Oh, actually, there's one thing that I will say that I haven't said on stream, and I've said it on Twitter a couple of times, but so obviously I'm contributing to Metasploit and Meterpreter in my own time along the way, but a lot of the stuff that I'm doing, particularly session-based stuffs, packet pivots, all of those sorts of things are actually being paid for by Rapid7. So it's important for people to know that Rapid7 are sponsoring a lot of this low-level work that I'm investing time in, so it's not free. So you guys should publicly shout out to those people for the effective sponsorship to get involved with this stuff and make this stuff happen. So big thumbs up to those guys. I love the Rapid7 guys, the dev team, the Metasploit dudes are fantastic. They're always great to work with. Brent's incredibly supportive. Egypt and Will, the bloody legends, all those kinds of things. But yeah, it's really important that everyone knows that this isn't just all off my own back, and that there's financial support being provided by Rapid7. So thank you guys, and everyone should thank them because they're awesome. Anyway, let's get back to it. So we want to be able to remove something, and so that is specific to the named pipe pivot code. Now let's go back in here. We need to create a function. We'll go static dword remove. Now this can be specific to this file. LP void context. So we know that in this case, the context that we're being given is a named pipe context. Not a named pipe transport context, but an actual context. Well, we should call that state, shouldn't we? That's what it's called behind the scenes. Equals named pipe context pointer state. Okay. Quick sanity check again. Make sure it's not null before going off and doing its thing. We need to return a result here, don't we? Return result. We should also indicate a response. So let's go else. At this point, actually what I might do here is go result equals error success. But here I'll change this to not found. So that's not found if we don't get an ID to search for, and it's not found if we don't actually find it. Otherwise, the result is success. So we should be able to go packet, transmit empty response, give it a pointer to the remote, give it a pointer to the existing packet, and tell them the result. So that does all the creation of packets and wrapping the result up and sending it down the wire, and done. Alright, so that tells us that we've effectively done what we promised to do. Now at this point, if the context isn't null, what I should be doing is acquiring the remote lock. Which would be part of the context, I believe, yep. And this will be lock release. So we want to make sure that nothing else is doing anything on top of what we are doing at this point. So how do we free up this context? So we should actually be able to just go, is it free named pipe? Maybe it's just close handle. Let's consult the documentation. Create named pipe. Create named pipe says once we've created the named pipe, we should be able to free it up using close handle. Okay, free resources used by named pipe. The application should always close handles when they're long and needed, which is accomplished by either calling close handle when the process ends. No, we need to call close handle. Sorry, back to here. Don't know what I just did, but hey, okay, so what we want to be able to do here is go context.pipe. Okay, so the pipe, that contains a handle to the pipe. We want to close that handle. Now, there's something else that we need to do. And that involves, where are we? Let me just show you. When we create this named pipe, which you can see here, this is where we're creating the pipes. We call this scheduler insert waitable here. So we need to remove this scheduler insert waitable. So once we've closed the handle, scheduler, let's see, signal waitable. Okay, so what we want to be able to do is pass in, what is it? It's context dot. You know what we should do is we should abstract this into something sensible. So we should be able to go, let's go static void, destroy named pipe context. Context. Yes. Let's put this in here because I think we're going to end up using this outside. Okay, so from here we can just go destroy named pipe context and give it the context. For now, we'll just return a success here. Okay, so what we're waiting on over here, scheduler insert waitable, was the read handler. Okay, so, and that would mean we need to, in here, we want to signal it with a scheduler signal. What is that? Pause, resume, and stop. We should be able to go stop. So we want to tell it to stop listening on that handle. We should probably do that before we close the handle on the pipe. And then once we've closed the handle on the pipe, we also want to close the handle on two things. The first is the read overlap event. And the second, I think we've got another, where is it? Write overlap. I assume that's what it is that we need to do. So if we look for write overlaps, let's see. We've got two overlap instances. Write file, where do we create this puppy? Get overlapped result. Here we go. So yeah, we're creating events manually here, so we need to make sure that we clean them up. So that's all good. So with those handles freed up, what else are we missing? We don't need to clean that up. We've cleaned that up. Ah, packet buffer. Yes, we should probably free up the packet buffer if it's not null. We're probably going to need to clean up the stage data as well. How is that allocated? Let's see. Yep, it's allocated, so we need to free that up too. Okay, so what we need is we need to go safe, free, context, stage data. There's a little macro there that makes sure that if it's not null, we free it up. What else? What was the other thing that I said we need to free? Context.packet buffer. Although, we probably don't need to do packet buffer at this point. We definitely need to do stage data. We don't need to do packet buffer, because the packet buffer is only used when we actually have a listener. So let's get rid of that. Okay, what do we got here? In what ways will your named pipe pivoting method be different from the SMB beacon in Cobalt Strike? Will it be full MSF integration versus just sending certain commands? Okay, so Powerful K9, the answer is yes, this will be a full Meterpreter session going through named pipes. I haven't used Cobalt Strike, and I'm not too au fait with how the beacon functions. But I'm fairly certain that the kind of things that we're doing, at least to interact via named pipes, will be similar insofar as the way the named pipe is set up and how you interact with it and that kind of thing. But the data that's going across the pipe is a full Meterpreter-based session. For now, what we're doing is we're trying to create a named pipe that allows anyone to write to it. If you don't have those permissions, it will just create a pipe that only administrators can write to. If you do have permissions, it will successfully create a pipe that anyone can write to inside the domain, which I'll demonstrate in just a minute. I will end up putting in some code that attempts to create null sessions, so anyone even outside of the domain should be able to connect to it and talk to it. I hope that answers your question. If it doesn't, then please let me know. Mugu7, destroy function should return an error value. Should it? It probably should. Well, okay, so let's ponder this. What happens if the destruction... What happens if the destruction fails? If it fails to free up memory, what do we do? Do we bail out? Do we care? Does MSF care? Probably not. There are no scenarios in here that anyone should really care about. I mean, if we are unable to remove the scheduled stuff, that shouldn't stop Meterpreter from working. The success of cleaning up the transport specific stuff isn't necessarily a concern for MSF. This is an interesting question though, right? I mean, if we were building software that was intended to be used in certain environments that aren't similar to what we're working in, then maybe it would be different, but I don't know. The way I see it is that we're going to attempt to clean up whatever it is that we can, based on what it is that we've whatever it is that we've allocated, whatever it is that we've created. But, you know, insofar as if any part of the removal fails, what are the scenarios that may happen? Are you being maybe interfered with? Maybe something else has got hold of a handle and freed it for you, or made it invalid or corrupted. But at this point, you know, if any of these things fail, it's probably fair to say that all bets are off. So the question then is, if these things fail, should you terminate the session? I don't know. I think that's a discussion that's probably worth having with the wider community. And I think to begin with, I will make it so that destroying the named pipe listener itself is not something that results in a fatal error should it not work. Yeah, I don't know. It'd be interesting to hear what you folks say. Why shouldn't we free things unsafely? Okay, so maybe I should be clear on what I mean by safe. Let me show you the definition of safe free. So safe free basically says free X and set X to null. Now I think what I had in here originally, and this may well have been changed, tempted to go and look for that. Let's have a look. GitHub Metasploit payloads. Actually, hang on, let me do this on screen here. GitHub.com Rapid7 Metasploit payloads. Did I type that wrong? Yes, I did. Okay, so C Meterpreter source. Actually, what I should do is go safe. That'll take me to it. There we go. Now I'm pretty sure that when I did this the first time, there was an if statement wrapped around this puppy. I am wrong. I am wrong. It was me. And that is not what I would have intended. So, instead, what should happen is this. If x. So SafeFree basically says if it's not null, then free it and set it to null. And so that means that like you kind of wrapped up the notion of SafeFree just in a macro, and it means that if you try and free it again, it's already been set to null, and so you know that this will not try and free it again. We don't want to do a double free sort of thing. So that's what that was intended to do. I have no idea why there was no check in there for that. That's just ridiculous. In fact, I can probably get rid of that outer check there. And let's scrunch this right up because it doesn't need to be any bigger. So yeah, there you go. That's the GO. Interesting. So why do you don't want to do double freeze, which I'm pretty sure. Why shouldn't we free things unsafely? So I'm sure that's what you're alluding to. We don't want to double free stuff, but we should always make sure that when we free something, we set it to null, because null is our base case to know that something exists or not. Is failure to destroy a signal of corruption? It might be, and that's the thing, we just don't know. It could be that something's already destroyed, it could be someone's tampering with it, it could be that various things are unstable, but given the environments that we're working in, it's kind of hard to know whether we should bail out at that point or not. What could you do about it if you did fail? Well, that's the key question. It's like, if we failed, what do we do? Do we try again? I would say that most people would prefer to keep their session running if they can. If you fail to free up a resource, then, you know, what can you do? Could be worth logging for debugging purposes to see when it could happen. Yep, that's true. It might. It might. Super Iron Bob. In the security sensitive code I've worked on, an unexpected failure is either ignorable because it's a signal that an untrustworthy component did something untrustworthy, or fatal because it's an unknown state and hasn't been reasoned for. Yeah, that's fair. I would agree with you, Bob. Mugu, why not memset 0? That's a discussion that we've been having for quite some time, actually, whether we should put something in place that forces memset 0 or, you know, scrambles memory before we finish up. Rather than implement it here at this point, I'm not going to change anything yet, because I think that discussion is ongoing. But it's a very key point. Do we want a 0 memory for everything? Do we want to scramble memory? Do we care? I think for the most part, it's probably fair to say that anytime we free things up in this manner, that we do want to memset 0. We do have other issues though. I mean, because we use malloc, calloc, realloc, and free. So that's using the C runtime library's memory management functions. We also use heap alloc. We use heap free. We create separate heaps. We use com memory. We use marshaled memory. We use C++ new, which behind the scenes, I guess, uses malloc and whatnot as well. It depends on the context. We also use virtual alloc and virtual free. And so there's so many cases where we're allocating and freeing up stuff. And if we're going to apply the DFIR style concern across the board, we should do it sort of in one fell swoop, and make sure that we handle all the cases rather than me just poking it in at this point. Obviously, each one of those things comes with a bit of overhead. And so the discussion is it worth doing that or is it not? But I think that particular decision is for the greater audience, and not just for me to make. So, but it's certainly a worthy discussion. I'd be keen to know exactly what it is that you guys would think. I think, to be fair, someone at some point, whether it's me or whether it's someone in the open source community that decides to turn around and go, I'm going to force 0 memory before we free everything up. But there be dragons in there. You make sure you want to cover every case. Because I think there may be the ability to expose issues that we never thought we had, but it doesn't make it not worth doing. Anyway, I hope that answered your questions and was at least useful. But yeah, feel free to keep asking those because they're good questions. Hey. Okay, so we can destroy our name pipe context now using remove listener. Now what we need to do when we create our name pipe context, sorry, not our name, our pivot contexts. What we need to do, we need to go, here we go, we're creating a new one here. This is for the client. What we need to do when we create a new server, pivot tree find, this is where we update. We need to add, that's right, in pivot listeners. Where do we use that? Here we go, pivot tree add. So pivot context remove equals remove listener. Okay, so now we've wired in the function that actually removes the listener from stuff. Now let's add a couple of things just so that we know things are going on. Printf pivot removing listener. We'll go named pipe listener. Now, what are we looking for here? I should put some of these at the end, shouldn't I? All right, so when we call remove inside here, is it? Sorry, server pivot. Okay, pivot tree remove. What we should probably do, what I've been doing is adding a little bit of debug output here. Get rid of session because it's actually not specific to sessions now. Pivot tree remove. So that only gets called once. Did you notice something? I noticed something. We've got pivot tree remove node, which does, you know, the behind the scenes magic, which means we need to do exactly what we did here for each of these. Because what we need to do in the case where the head is being removed, we've got a special case. Where the children are being removed, we've got a couple of special cases because you want to make sure that you update the parent references. But anyway, that's the go. So here, what are we doing here? Null. Removing null. Okay, so if parent GUID is this, so this doesn't look right, does it? Oh yeah, it does. We should never get to the point where we're actually referencing ourselves as the one to be deleted, so that should definitely return null at this point. Otherwise, yeah, otherwise we basically say go and look at the children, so that should be okay. Let's fire this up and see if we can demonstrate the ability to add or remove our pivot IDs. All right. While that's kicking off, probably a question on consumer of the name pipe. Is there value in putting the pipe in a namespace directory or not in this context? That's a good question. Maybe we need to provide the means for that to be available. For the first pass of this code that actually finally makes it into MSF master, I'll keep it as is, a fairly simple, just based on name. But we may down the track, if we find it useful, if there's some value in it, then yeah, absolutely, we could put the namespace in whatever namespace or directory, named pipe, sorry, in whatever namespace or directory makes the most sense. But that's a good question again to have in IRC in the Metasploit channel. Okay, I hope that answers your question, Bob. All right, what have I done? done something stupid. D-word, of course it does. There we go. Right, so what was I going to do? I was going to come up with a way of listing the listeners. Oh, no, actually, we don't need to do that, do we? Yeah, actually, I'll do it from here. Pivot dot get listeners. We could probably remove this after the fact, but I'm just going to go client dot, what was it, pivot listeners? Yeah. Pivot listeners. Yeah, and then I can just inspect those. So it does. Thanks. Pleasure. Thanks for the question, mate. It's a good question. Let's refire that up. And that looks like it's built. Make install Windows. Excuse me. Maybe what I should do when we create the listener. Where are we? Create a name pipe listener. So the name pipe listeners get an identifier based on, I think, just secure random creating UUIDs, right? So the listener, right? And there it is there. So pivot.new, that does return. Where are we? Create listener. Do I actually return the pivot? I don't think I do. Let's return the listener. Because then we can even retain a reference to it instead of having to type stuff in. Let's exit out of that and do that again. Because then when I drop in IRB, I can say, just keep a reference to the listener itself. And later on, we can go through and iterate and provide lists for people to say, I want to get rid of this one. But programmatically, we're only interested in references at this point. So let's see how well this does. TCP, a lot of debug output, yeah. Okay. Let's paste this in again. Ooh, look at that, something broke. Given 1, expected 2. Really? Where did it break? Initialize. Ah, yes, okay. Right, I blame you people for not picking up on my stupidity. We should be passing the display name into the pivot listener constructor, not into the add pivot listener. Let's see if we can do this. Load librex post meterpreter pivot.rb. I don't know whether this is going to behave the way I want it to. What has it done now? 113. Local. Ah, yeah. I should put the display name up here first, right? Idiot. Oh well. There we go. Okay, so I did the stupid thing though. I'm going to exit out of that. Reload. Change my clipboard thingy over here so that I retain a reference to that pivot. Okay. Okay, there we go. So now I've got P, which is a reference to a pivot, and we can see it's got an ID behind the scenes, right? So if we fire up debug view, okay, what happens when I do, what do I call it? Pivot.remove listener. If I do get listeners, of this, we should at least see one. There you go, there it is. And then you can see that the display name thing has come through like we wanted it to, which is good. Let's go pivot dot remove listener client p.id. Okay, here we go. Let's see what happens. We sent. Oh, look at that. That looks like it's actually behaved itself. Pivot get listener pivot remove. Seems to have sent. It's got a core pivot remove response with a result of 0. If we list listeners, there's no listeners left. Let's see what we got here. Pivot tree, removing GUID, removing name pipe listener, leaving scheduler loadable. Did that just work? Removing name pipe listener. Wow, okay, so it's gone. There's always a catch. It looks like it's working. Something somewhere is broken. We just haven't observed it yet. That's what I'm going with. If anyone out there is surprised, they should be. But by the looks of it, they did actually remove the listener. So what we should do now is let's recreate that listener. And there we go. We can see pipe test. Let's create the new pipe session. Now we should be able to remove that listener again. There you go. There's the listener, not the client. We should also be able to go pivot. Oh no, let's go client dot pivot. Is it pivots or pivot sessions? Pivots. So there you go. There's the pivot, an actual pivoted session that's active. If we remove the listener, everything should work as expected. Should be no pivots. There should still be a pivot attached, and behind the scenes our process explorer should show. Ooh. Ah, yes. Now this is interesting. So the pipe should still be there because it has a reference to this pipe test over here. So see that there is talking to that there, and so when we remove the session, this should all disappear. Now I know when I typed exit last time, shit went bad. Let's just see what happens. There you go, still going bad. Okay, I don't know why that's the case, but you know, that's probably the next thing that we need to fix, is to make sure that when we type exit on the named pipe session, that stuff behaves as we would expect. What happens if you create another pipe with the same name? Well, absolutely nothing. It will let you do it. So you can create a pipe test, you can create another pipe test, and you can create another pipe test. The problem is, well, actually, no, let's test that. My understanding, actually, before we go ahead, my understanding of it is that you should be able to create as many instances as you like of the same named pipe. The problem, obviously, with this is that you can have different listeners on the same pipe name, but you don't necessarily know which one's going to get the call. So, I mean, I think a lot of named pipe servers will spin up a bunch of instances that are effectively listeners so that they've got multiple things to listen on when one becomes free. We're only spinning up one. So if you had 1,000 sessions come in at the same time, then you're probably going to have issues here. Perhaps down the track, we'll get to a point where we can say, hey, you know, I want to be able to create 5 of these server contexts, and, you know, off they go, and sit those behind the scenes. in the current state of play, we're literally only going to deal with one, but that is not going to stop anyone from doing it with the same name. There are parameters I think you can specify with creation of the named pipes. So let's go and look at the documentation for that again. There are flags here that let you say certain things. Now let's have a look. Connections from the remote clients can be accepted and checked against the security. We don't care about that. Connections from remote clients are automatically rejected. Nope, we don't care about that either. Where is it? Where is it? Where is it? So there's this flag first pipe instance. If you attempt to create multiple instances of a pipe with this flag, creation of the first succeeds, but creation of the next instance will fail with error access denied. So that basically means you can only get one, I believe. We don't want that either. We actually want to be able to create a named pipe and recreate it and whatnot after the fact. So that doesn't apply to us. I don't think we can actually force other instances to fail on creation. Call provide access name pipes. Yeah. See, none of this is really that important. Access security, pipe mode. Don't have to worry about that at this point either. Although I'm sure there's something going on with the way the name pipes are working, forcing message mode on me or something similar, but I haven't figured out how to introspect that just yet. What else have we got? There's nothing else in here, I think, that's relevant. Create an instance name pipe. The user must have file create pipe instance access. Yep, that's not surprising. This is all pretty boring guff. I've read that 1,000 times and there's nothing in there that's actually relevant. So, but let's give it a spin and we'll create two listeners with the same details. I'm pretty sure that it will just work. Move this down a little. Wolf, does that help? I don't think it does help you much, does it? Sessions. Okay, so let's create a listener with this session. Okay, so there's one. There's two. So according to this, there's probably, there you go, there's two of them. So this is one of those cases where with great power comes great responsibility. It's fairly easy to put limits on this, but limits are not really what we're interested in. I mean, if people want to create name pipe pivots and they make the mistake of using the same name, then there's probably not a lot that we can do about it. We could, I guess, track it locally, but the problem then is, okay, where do you begin to track it? Do you track it in Meterpreter? Do you track it in MSF? Do you track it in both? Like, what happens when you have multiple sessions on the same machine? I don't know. We can spend a lot of time engineering a lot of protective mechanisms in here to stop people from creating name pipes with the same name, because we are staging. Clearly, we are putting code on the end of the name pipe saying when someone connects here, give them this. However, I think the time is better spent on engineering other features and adding stability and figuring out other bugs that we need to fix, rather than preventing users from doing silly things like creating multiple instances of the same pipe. What we will do though, let's go pivot.remove listener client P. I think that's what we did before, and then is it P2, the one that I created just then? Where is it? P2 and P. Okay, so I should be able to do pivot dot remove listen p2. Okay, so forward goes to plan, which it did not. Probably because the references are invalid or something. Client dot pivot. Okay, so they're both still there. Let's do this. Client dot pivot listeners. Can I do dot first? No. I hate Ruby. Ah, I've got to use the ID. That's my problem. P.id. There we go. Who wrote this API? Oops. There we go, they're both gone now, so that did work. Alright, so let me just address it. Was more curiosity on how TT was handled. And if things explode or not. Sorry, I'm not sure what you mean by TT, Wolf. Can you explain it for the sake of the plebs like myself? ACLs and name uniqueness are usually the way to guard against misopening kernel objects. Okay. But name pipes aren't kernel objects. Yeah, I hear. I'm the same boat as you, Bob. I can't comment too much on that. But, I mean, given that technically the name pipe, at least in this case, is userland and it maps to a kernel object, I think behind the scenes the kernel object will probably have its own identifier. But locally, I mean, there's nothing wrong with creating multiple named pipe instances if you want them. You know, that's what SQL Server and things like that end up doing. Wolf, TT equals it. Oh, okay, thank you. More curious on how it was handled. Yeah, so you can create a bunch of name pipes, all of the same name, and I think when a connection comes in, the OS decides which one gets the connection. I don't think you can control which one gets the allocation. Interesting though. Okay, so where are we at? We know that we can remove pivot listeners. We know that we can add pivot listeners. When we remove a pivot listener, then the pivot still exists, which is good. We don't have the ability yet to remove pivots in this way, but that's okay because they're kind of technically mapped to sessions. The problem that we've got right now is when we exit out of a pivoted session, things go a bit bananas. So let's have a look. Is there an exit? I don't think there is. So we're going to have to figure out. I should probably do another, what's it called? Another little command console doohickey. Let's do that. Framework, and let's do some grepping. Def command exit. That'll tell us where it is. Meterpreter UI console command dispatcher core, of course. Meterpreter command dispatch core. There we go. Okay, so client.core.shutdown is what gets called. So let's do a couple of things. Calling shutdown. Now I'm expecting this to be lost in a sea of noise. Calling shutdown, passive dispatcher. Stopping the shell. Now I would expect this line to fail for some reason. Because what we will need to be able to do once we're done with this is make sure that the session that we're pivoting through is informed of the fact that the session's disappeared. I will figure that out in just a minute. So remove this from the pivoted session metadata if this is a pivoted session. Okay, nothing too crazy there. For what it's worth, it's way more interesting doing these streams when people ask questions like this. So please keep them coming in. Alrighty. Just getting rid of some noisy emails. Alright, let's do this again. And see what happens. Did I not double click on that? Clearly not. There's also some fun involved in double pivots. So if a packet comes in, let's say you've got MSF here, you've got your first Meterpreter session here. The second session pivots through the first. So the first knows about that pivot session because it came in by itself. And so what happens then when this Meterpreter session over here becomes its own pivot point? And then another session is established and pivots through that. So when the packet comes through, what needs to happen is the pivot at this location needs to start tracking the pivot at that remote location so that it knows which named pipe transport to pipe that session through, because this needs to know that responses intended for those sessions all the way over there need to go through that channel. So you kind of have this nested hierarchy of pivot tracking. At this point, I think for the first pass, we might make it so that you can't do that. Or I should say at least not actively prevent it, but warn people against it. Because that sounds dangerous. Okay. So that should have created our pivot listener. Let's check. There it is. Let's pivot through that listener. Okay. I'm going to kill that off, and then I'm whacking something on the clipboard so that I can kill this very quickly. All right, here we go. So I'm killing the second session, which I think will cause debug output up the wazoo. That worked better than I was expecting. Okay, so let's see what it does. Sessions, killing session 2, which is the pivoted session. Output session 2 closed. Outgoing packets, blah. Okay, so that... Did that actually work? Okay, so that appeared to work, which is a little concerning. That sort of highlights that the functionality of sessions-k is not the same as the functionality that we see in command exit. Obviously we didn't see these because of reasons. That does beg the question though, why does sessions-k behave differently? It should effectively be exactly the same, except for the fact that there is a shell attached here. What does shutdown passive dispatcher do? And where is the code that's associated with it? I would argue that's probably in client core. Or just, oops, what have I done there? Nope. There we go. Okay, so we've got client core.rb, which is, that's the one we want. No. Yeah, I guess not. Oh, well, let's come back to that and just kick it off anyway. most people are going to interact with the session and type exit in that way anyway, so it's clearly important to cater for that case. Pipe test. Ooh. It didn't stage. Why didn't you stage? That's fascinating. Why didn't you stage? Why didn't you stage? Something's up. It's concerning, isn't it? I didn't change anything, I don't think. Worked that time. Yay, stability. Yeah, still definitely works. It's way... So the original implementation that I did of this as part of a previous pull request, what it did was it created the named pipe, and it would attach a server channel to it. So MSF had a named pipe channel type added to it. So we would tie that channel type to the listener. And then when a connection came in, we did the create a new listener thing, established a new server channel to point to that, and then swap the existing server channel to a client channel, and then attach that to a session. And so the session pivoted through the channel, and that meant that every single packet that went across the wire was wrapped in another TLV packet that contained UUIDs, channel IDs, and blah blah blah. So the overhead was quite noticeable. And this, to me, is, even though it's clearly slower than a standard session, it's way faster than the previous implementation of named pipe pivots, which is good. Okay, so what do I need to do? I want to be able to go... what I'm copying and pasting here is the command exit, followed by sessions-k, followed by exit-y. So that's me forcing everything to shut down so that I can see what the output is. And it looked like it behaved. Did it? Calling shutdown, passive dispatcher, stopping this. It worked. And they closed down. Isn't that interesting? Alright, anyway, when we call core client.core.shutdown, what we should probably do at this point, if client dot is it pivoted session, pretty sure that's what it needs to be. Pivoted session listener dot session. Okay, so that creates a new session. So the pivoted session is the thing we're currently closing down. So create that. So we need to inform. So we are the pivoted session, and we need to look at, what do we need to look at? Let's have a look at the dispatcher for a minute, because I'm pretty sure pivot self.find pivot packet session GUID. So that's dispatching inbound. So we have the ability to find a pivot based on the GUID to match the pivoted session. Pivot is pivot.inspect. We only get the TLVN key if there is a pivoted session. So we want to go the other way now. We want the pivoted session to have a reference to the thing that it's pivoting through. So that means we want to dispatch, we're effectively looking for, you know, the transmit of the outbound packet. Send packet. Right, so if we are a pivot session, sorry, if we have a pivot session, that is confusing me. This makes a bit of sense. Or does it? Maybe I think I might need to rename this thing, because I'm slightly confused by it. So this is where we're using it. This is where we're creating it. Okay, so the pivot session is the session that we're pivoting through. That's what that reference is. Is that right? No, it's not. No, it's not. It's not. So up here, when we handle it and it's a new session, we can get rid of that now. We get the session GUID and the pivot ID, and we create a new pivot based on, okay, yeah, the current client instance. Okay, so it does do that. So this is indeed the session that we're pivoting through, not the session that is being pivoted. That makes sense. And then what we do is we add pivot self. Right. So that means if we're back in our dispatcher here, if we have a pivoted session, then we've got a session we're pivoting through. Client.pivoted session dot remove pivot client. I think I'm going to have to do more than that. So did I call it pivots? Pivoted session. Okay, so this says, do we have a session we're pivoting through? If we do, then we need to remove it somehow. So let's go back here. So we've got this initialize, that gives us a pivot. We need to find a pivot, don't we, based on something. So find pivot based on the pivot session GUID. We know what that is. Okay, so that also means we should be able to add pivot, remove pivot based on the GUID. Okay, so pivot session dot remove pivot based on our current session GUID. So that should be it, yeah? Once we shut that down, client.session GUID.inspect. try that again. Everyone's gone quiet, so I assume you're either bored or I'm doing a fantastic job of explaining myself. I think it's the former. Let's do this again. This time, I'm not going to paste those 3 commands in. And I'm going to have to turn off the stream in about 10 minutes because my kids will be getting home and they'll be going bonkers. So, let's just hope that this becomes functional. So last time I did exit, things just went a little bit loony. Let's see if it does it again. No. Look at that. Removing session. So that means if I go back into the original session, client.pivots is empty. It worked. Well, there you go. I don't know why, but it worked. Okay, so we now have the ability to add and remove pivots and pivoted sessions. Let's, before we remove the pivot, let me add another one to make sure that it reconnects, because I think this was a case that we had before where it didn't. Yeah, see that? And nothing happened. So what happened here? Let's see. Pivot nil. Aha. So pivot session new, UUID session good. So this is interesting, right? Because you can see we're getting different session GUIDs here. Which is very strange. What is this telling us? A lot of noise in here. So clearly it's staged, otherwise we wouldn't have seen this. In fact, let me kill this pipe test off. We also need to handle things in the other direction. So if the session crashes, Meterpreter needs to go, hang on, this session's just died. We need to tell MSF that the session that's associated with this pivot has died. We'll need to do that in just a minute. But in the meantime, let's just run this again. Okay. Yeah, so it definitely stages. Oh no, hang on, that's 6. Here we go. Stages. Does its thing for setting up. Adds GUID, resetting event handle, kicking off another read. Okay, so this is interesting because for some reason when we do that the second time, there you go, core pivot session new. We get a request that comes in. So that should lead us down the path of this here. We get the session GUID out and the listener ID. Ah, is that the problem? Isn't that interesting? Yeah, look at that. It looks like something is messing up this time around, doesn't it? So session GUID comes through for the new session, but the listener ID isn't there. Okay. Ah, haha. I know what's going on. Okay, we should be able to squeeze this in before the kids get home. So our server pivot name pipe, when we create, where is it? Server notify. When we create our new context, next context pivot ID. We've got to copy this over. MCP1. That's important. We have no way of tracking that otherwise. So the source would be server context pivot ID. That's why. So we didn't have the ability to tie a pivot identifier back to MSF. Now what this also highlighted for me was Rex post interpreter packet pivot ID. Yes, we don't have any of these in inspect. So let's add them. I hate it when it does that. Something about Vim. Gotta love it, hey. All right, let's try and be tricky. That's not what I wanted. Neither's that. I should just do it manually instead of macroing everything based on time. There we go. Actually, oops, D to TP. There we go. That's what we want. Okay, so now that should actually, this thing over here, which we saw coming out with an unknown, this unknown blah, 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 we should see that as a pivot identifier when it gets spat out. Now, did we build this? We did build this, didn't we? Nearly done. Thought I did build it, clearly not. Come on, come on. There we go. Okay. Moment of truth. Let's see if we can get 2 sessions out of this. Create the listener. Session 1. Session 2. Yay! It's working! Oh, hang on. I ran the wrong ones. That's what I wanted. There we go. Okay. Let's create another one. It doesn't look good, does it? Okay, let's see. Pivot ID at least is coming through appropriately, right? It's doing all the stuff I would expect it to, but I'm not seeing anything like what I want to see. There you go, that's still missing. So maybe there's something else that I am not doing correctly, and it could have something to do with the way the function pointers are set up for dispatching. So maybe that's what we need to quickly check. What else have we shoved in our context, which is important? So pivot ID is it's definitely a period. Next context. What are we not passing off that we really need to pass off? Stage. See all that over. Yeah, that's all right. Yeah, okay, I know what's going on. Right, okay, there's quite a bit that we're missing. Oh no, it's done in here, isn't it? Create pipe serve instance. Creates the security attributes. Creates the events. Okay, so that's not the issue. Connecting, establish, connections false, establishes false name. That's being copied here. Right, we've got the pivot ID now. Rebuffer. Remote, stage, and right overlap. According to what I'm seeing, that should actually just work. And so I'm going to have to dive into that into a little bit more detail. But anyway, I'm going to wrap this little session up. Hopefully you guys got something out of it. You can see how close we're getting now to having something fairly functional. And there's just a little bit more accounting we need to do at either end. I need to just figure out what's going on here with the second session, but that'll be something fairly trivial when it comes to sort of handing over the named pipe related bits and pieces to the next listener. But yeah, I'll get stuck into that off stream, and hopefully very soon we'll be at a point where we can release this for you guys to play with. So thank you very much for tuning in and for the great questions. Bob, Atwolf, Mugu7, Kane, all those guys, thank you very much. Love your work, and enjoy yourselves. Be good. If you can't be good, be good at it. See ya.